Welcome back to Aurora Tech Channel. Today, I'm going to review the GENMITSU PROVerXL 6050 Plus CNC Router, which is the largest machine I have reviewed so far. As its name suggests, the working area measures 600 by 500 millimeters, and the Z-axis travel height is 115 millimeters. The shipping weight of this machine is 133 pounds, so the net weight should still be close to 130 pounds. The frame of the machine uses thicker 20 by 80 extrusions with 12mm solid aluminum plates. The motion system consists of 15mm dual linear rails on the X and Y axes, and 20mm linear rods on the Z axis. It comes with a 300-watt spindle and also includes an extra 65mm mount for a more powerful Makita or DeWalt wood router, as one would expect to work on metal with a more aggressive speed using this sturdy machine. There are also NEMA 23 100mm stepper motors, which are larger and more powerful than regular 57 or 76mm motors commonly seen on other CNC machines. The bed is a T-slot MDF hybrid bed that can be replaced independently. There are two limit switches installed on each axis, and there's also a Z-probe and an electronic enclosure that houses all the TB6560 stepper drivers, the motherboard, and the 600-watt power supply. There are some basic buttons and a spindle speed control knob on the panel, while the offline controller is available as an optional upgrade. This machine seems pretty robust. I would like to thank GENMITSU for sending me the machine to review, and with that, let's get started. The machine comes in a large box and weighs 133 pounds. As we couldn't move the whole thing on the table, we actually opened the box on the ground and moved the parts one by one to the table. The base is mostly pre-assembled. You need to put together the Y-axis lead screw and 3 NEMA 23 stepper motors for each axis, but the gantry with the Z-axis is also pre-assembled. We also have a controller box, the spindle with an aluminum mount, the bracket to hold the gantry, a cable chain, the T-slot MDF hybrid bed, user manual, cables, some loose parts, and there's also an extra mount if you plan to use a wood router. Putting this machine together will take around 1.5 to 2 hours. All you need is the user manual, a bit of common sense, and most importantly some strength, which we struggled with. I will start by placing the rubber feet under the base while the machine is not that heavy before assembling. Next, insert the lead screw, a bearing, and the Y motor. Make sure it can move freely. If you didn't install the motor parallel enough to the lead screw, you will find it hard to turn with the manual knob. You may need to adjust the screws to make it turn smoothly, even with your fingers. Don't over-tighten these 4 screws on the motor. This applies to the X and Z axes as well. As I mentioned, common sense is also important when assembling this machine. I forgot that the machine was flipped to the back when I was installing the stepper motor. That's how I initially tried to install the gantry, but it was obviously in the wrong direction. So common sense is crucial and I had to flip it back. To install the X-axis motor, just be careful to ensure it's parallel and avoid over-tightening the 4 screws. The same applies to the Z-axis motor. Then, install the spindle mount, spindle, and the rest of the assembly will be pretty straightforward. Install the Y-limit switches on the left side of the gantry. Then, mount 2 brackets for triggering the Y-limit switches. Mount another 2 brackets for the cable chain, and now you can put the chain on the left side of the machine and the other end on top of the gantry. Connect all the motors, the spindle and limit switches cable, and we are almost done. Put the detachable bed on the base, connect the cable to the controller box, and I will connect it to the computer and home the machine. It seems all axes are working fine, and the spindle is also working. The machine is homing to the top right by default. I will like it to home to the bottom left, and as it has limit switches on both ends, I can just change the GRBL settings to make it home to the other corner. I have also adjusted the homing speed to be a bit faster from the default 500 mm per minute to 1500. I put the GRBL command reference table under the description. Before I start using the machine, I would like to test the effective working area and Z travel. I let the X-axis move from edge to edge, and the effective length it can travel is 602.5 millimeters. For the Y-axis, it's 501 millimeters. Finally, the usable height for the Z-axis is 119 millimeters, so it seems all 3 axes can travel a bit more than the machine claims. It's not a huge deal, but it's definitely better than having less than the claimed working area. The footprint of this machine is large. A standard 24-inch bench should be able to hold it, but as the Y motor sticks out about 6 to 7 inches, and the cable chain also needs another 4 to 5 inches of space, if you want to make an enclosure or let it fit on a table placed against a wall, it would be better to have a 36 by 48-inch bench. As I just put it on my regular stand desk for review, when the machine is operating you can see the table shaking. It's especially obvious when you look at the 3D printed Jeep. The machine also comes with a set of clamps. I will mount my mini vise on the left as I will work on some metal plates later. I will install an engraving bit and test the Z probe as well. Let's start with some MDF engraving and cutting. I will move it to the starting position and generate some simple G-code from Fusion 360. I will just make a plate and put some text on it. The preview looks fine, so let's load the file from the Candle controller software that comes with the machine and start the job. The result looks alright. I will change to a flat end mill, which also comes with the machine to make a slot. But first, I need to set the tool height with the probe. Then, I will run a contour to cut it out. It seems the slot is too close to the contour, but I will just let it finish and see. As the space between the slot and the contour is too close, I will peel it off and sand it down. I just used 220 grit sandpaper to sand down the edge, and the result still looks okay. Next, I will try some 1/2-inch red oak solid wood and make a Transformers Autobot logo. I will start with engraving and set the tool height again using the probe. As I don't want to clean the groove manually, I will just let it run another pass. Okay, it looks better, so I will now run a contour to cut it out. As I didn't leave any tabs, I just babysat the machine and stopped it once the board was cut through completely. I cleaned it up with a nail file, and the result looks pretty good. Up next, I will try some 3mm clear acrylic. I will start by engraving a minion on it. I just set the depth to 0.5mm to engrave one pass. As you can see, engraving acrylic may need another cleanup pass, so I will run the same G-code again. After another cleanup pass, it looks really nice. Then, I will change back to the 1/8 inch flat end mill, drill a hole, and run a contour to cut it out. I don't use tabs, so the part just pops out. As softwood, hardwood, and acrylic aren't really challenging materials, I will now try some metals including brass and aluminum. Let's start with cutting brass plate. I don't want to start with a 0.1mm step down or a 100 milliliters per minute feed rate like a small desktop machine, as I would expect more from the weight and sturdiness of this machine. I will just double everything and use a 200 feed rate and start from a 0.2 step down all the way to 1 and see how far I can push it. As the spindle is just 300 watts, I think it would be better to stay in the 0.2 or 0.3mm step down range with a 200mm per minute feed rate. If it's more than that, the finish will be pretty rough. Let's see what happens if I run the same G-code on a piece of 6061 aluminum. I think the result on aluminum is a bit worse than brass, as I can't see the same smooth finish like the brass even for a 0.2mm step down, especially when it plunges down, as the tool is shaking and making these inconsistent results. The machine is still rigid, the bottleneck is mainly the spindle. So, I will replace it with a 1¼ horsepower Makita router and see the difference. I will run the exact same G-code and set the speed of the router to around 4 out of the maximum of 6. This will be around 20k RPM, which is way faster than the stock 300 watt spindle 12k RPM. I think the result is much better, so the 1mm step down using the Makita router is better than the 0.2 step down of the stock spindle. I will also do the brass again with the same G-code using this Makita router. The improvement is obvious. I think using the Makita router can easily do as much as a 0.6mm step down with pretty good results. In fact, the 1mm step down still looks fairly decent. Finally, I will use this setup to do some modifications to a cast aluminum 3D printer Y carriage plate. I need to upgrade an early version of the Neptune 4 Pro X and Y motors from a 34mm to a 40mm. However, as the length of the motor increases, the bed carriage will bump into the motor before the limit switch is triggered. If I didn't have a CNC, I probably would have just moved the limit switch forward as a quick fix, but this would decrease the usable Y-axis by around 12mm. So I decided to cut out a little bit from the Y carriage to address this issue. I'm going to use a 200mm per minute feed rate and a 0.5mm step down. I will just make a pocket so the tool is cutting the air half of the time. Okay, it's done. I tried to manually stop the program, but I pressed the wrong button, so I found out that surprisingly, the machine can cut through the 4.5mm thick bed carriage in a single pass. Of course, the finish is super rough, but the edges of the actual pocket it cut was very nice, even at a 0.5mm step down. As the Y carriage is ruined, I found another unused Y carriage plate, and this time, I sped it up to a 300 feed rate with a 0.5mm step down. As the shape of this Y carriage is quite different from the stock one, I have to cut it even more for it to fit the stepper motor. The result looks pretty good. I can now print at 300mm per second with the 5K acceleration without any layer shift caused by the stock stepper motors. Okay, let's talk about the pros and cons of this machine, starting with the pros. 1. Other than the 3 thicker 20x80 aluminum extrusions, the frame of the machine is made from 12mm solid aluminum, resulting in a total weight of around 130 pounds. It's not the best idea to place it on a regular table, so you need a sturdy workbench for it. 2. The motion system on the X and Y axes consists of 50mm linear rails. They are rigid and move smoothly, allowing the machine to reach a top speed of 2,000 millimeters per minute. 3. The total usable working area is slightly larger than what it claims, especially for the Z-axis. It can travel up to 119 millimeters, which may not seem like a big deal unless you really need that extra few millimeters to work with a taller piece of stock. 4. It was a good idea to offer an extra mount for the Makita and DeWalt router, as they are powerful and inexpensive. I can work with aluminum and brass with up to a 1mm step down with the router upgrade, and as you can see, I cut the second Y carriage plate at 300 milliliters per minute and a 0.5 step down with pretty good results. I can definitely push it harder, but considering I don't have more spare Y carriages, I didn't push it that far. 5. The dual limit switches on all axes are quite handy. For example, if I don't like the default top right homing direction, I can easily change it to the lower left. Additionally, the limit switches are of very high quality. I increased the homing speed from the default 500 milliliters per minute to 1,500, and they still work well. 6. The small details like the cable chain and the manual knob on each axis are useful. They allow you to manually fine-tune all axes to the starting position and zero out the X, Y, and Z axes on the software. It would be even better if another knob was installed at the front of the machine for the Y-axis, because the knob on the motor at the back of the machine is hard to reach. Now for the cons. 1. The assembly time of the machine was longer than I expected, because there were more loose parts compared to the ProXL 4030 V2 that I reviewed weeks ago. That machine was much easier to assemble. 2. The smaller ProXL 4030 V2 uses ball screws with palm wheels, while this ProXL 6050 Plus machine uses linear rails but lead screws. I believe this machine deserves ball screws. They can provide smoother motion and better accuracy than lead screws, and there's no need to adjust the anti-backlash nut when installing the Y-axis, since the ball screws are all pre-packed at the factory. 3. The machine comes with 4 clamps, but it would be better to include a mini vise. When working with smaller stocks, I prefer using a vise over clamps. 4. The machine also includes some basic bits, but there is no label or specs for those bits. At the very least, a table or label specifying the specs of the bits is needed. It would be even better if a Fusion 360 library was available to import into the software, so you don't have to measure and add every single bit manually. In conclusion, the ProXL 6050 Plus can work with softwood, hardwood, acrylic, and soft metals like brass and aluminum. This machine is more than sufficient for metal part production at an acceptable speed and with presentable quality with the Makita router upgrade. The weight and sturdiness of this machine also contribute to less vibration when working with metals. I can push the step down all the way to 1mm at a 200 milliliter per minute feed rate with pretty clean cuts on both brass and aluminum, which is quite impressive. There is also another machine in the same series, the ProXL 4030 V2. Its performance is quite similar to the 6050 ProXL Plus. If size matters and you need the 600x500 table, this machine is an excellent option. If not, you can definitely choose between the ProXL 4030 V2 and the ProXL 6050 Plus. Ideally, I would combine the ProXL 4030 V2 servo motors and ball screws with the 15mm linear rails on this ProXL 6050 Plus. But of course, this would also increase the cost of the machine, bringing it closer to the $2,000 mark. If I had to choose one, given that I already own a 6090 machine with a 2.2 kilowatt spindle, I would honestly prefer the ProXL 4030 V2, which comes with servo motors and ball screws but without linear rails, as its size and weight are just more manageable for me. However, if you don't have a large machine and are looking for a mid-range CNC with a relatively big working area that can handle a broad range of materials, the ProXL 6050 may be more suitable for you. In any case, I included links to both machines in the video description. That's all I wanted to share about this machine. If you found this video helpful, please consider giving it a like and subscribing to our channel. Thank you for watching, and I will see you next time.